So we've been talking quite a bit about parallelograms, and now we're going to talk about something that isn't a parallelogram, and this is a trapezoid. So the reason a trapezoid is not a parallelogram is because it has only one pair of parallel sides. The legs, these are the legs that I'm drawing, sort of like the legs of a triangle, how they're kind of diagonal and standing straight up, sort of like legs are on a person. The legs are not parallel, and they may be congruent and they may not be congruent. Alright, so those sides, just like on a triangle, are called the legs, and just like on a triangle, this is called a base, and so is this. So not like a triangle, it has a top, which is also called a base. So those two parallel lines are referred to as bases. Alright, so this is an example of an isosceles trapezoid. It has one pair of parallel sides, just like any other trapezoid, but its legs are both congruent. So just like on isosceles triangles, where the legs are congruent, it also has pairs of base angles that are congruent. So these base angles are congruent, just like they would be on a triangle, and these angles up at the top are also congruent to each other, not congruent to the ones on the bottom though. And as long as your trapezoid is an isosceles trapezoid, the diagonals are also congruent. So this line is congruent to this line. You can see in the picture they don't bisect each other, but they are the same in length. Alright, so those were examples of isosceles trapezoids. And as long as the two base angles are congruent, the shape is a trapezoid. If it is not isosceles, obviously the legs will be different in length. So you could even have a trapezoid that has a right angle in it. So here's a trapezoid that has the bases parallel to each other, and it has a right angle here, and you can see that these legs, this leg and this leg, are not congruent. So these are not isosceles trapezoids that I just drew. This side is a different length from that side. So one fun thing that we can do with trapezoids is use the mid-segment theorem. And it doesn't matter if our trapezoid is isosceles, like my trapezoid on the left, or is not isosceles, like my trapezoid on the right. I can still use the mid-segment theorem. So the mid-segment is a line that you can draw in the middle of your trapezoid, so equidistant from the top and the bottom. It runs through the middle, and it is also parallel to the bases. So that line that I just drew in gold is called my mid-segment. And what's cool about the mid-segment is you can average the top base and the bottom base to get the mid-segment. So it's equidistant between the two, so I can just average these two things to find the mid-segment. So if you remember, in order to find the average, you need to add together however many things you have and divide by that number of things. So in this case, we only have 2 items, so we add them together and we divide by 2. And that goes for any trapezoid. So we could also find the mid-segment on this trapezoid, and it would be the same idea. You should be averaging this with this. And sometimes you'll be given numbers, and sometimes you'll be given expressions with variables in them that you'll have to solve for that variable. But what the mid-segment does is it splits these into equal pieces. So actually, on my isosceles trapezoid, it would split everything into equal pieces. On my not isosceles trapezoid, it would split them into equal pieces on either side. So this left side is split equally, and this left side is split equally, and this right side is split equally. But they're not equal to each other because these side lengths are different. So that's the whole idea of a mid-segment. So let's summarize what we know so far. We know that quadrilaterals are 4-sided figures. It doesn't matter what they look like as long as they have 4 sides. So we know quadrilaterals have 4 sides. And then we introduced a special kind of quadrilateral called a parallelogram, and we know that parallelograms have to have opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals that bisect each other, and consecutive angles that are supplementary. So a parallelogram, you can see I drew some parallelograms here, can look like this. This is sort of like our classic looking parallelogram, or a parallelogram could be these special cases of parallelograms that you just learned about. So our three special parallelograms are rectangles, which have 4 right angles, rhombuses, which have 4 congruent sides, and squares, which have properties of both of these figures. They have 4 right angles like a rectangle, and they have 4 congruent sides like a rhombus. Alright, so where do trapezoids fall into this? Well, if you remember back at the beginning of me talking about trapezoids, I said they don't fall under the parallelogram qualification because they don't have 4 or 2 pairs of opposite parallel sides. They only have 1 pair of opposite parallel sides. So, trapezoids are not parallelograms, but they are quadrilaterals. So trapezoids do not fall under the parallelogram category. Instead, they are simply quadrilaterals and they are in their own group.